did it way better. So hopefully, if yesterday was hard for you, that today will make a little bit more sense. But we are moving on. So if you're having a hard time with right triangles, watch this carefully. Now the video will be I videoed in third hour instead as well. So my video will be teaching it the way I taught the other hours that understood it better. So you need to be getting on and watching that. But here we go. So we have a right triangle, and yesterday we learned if we have a huge right triangle right here, and we drop an altitude down, then we have two more right triangles that are formed, a small right triangle and a medium-sized right triangle. Now keep in mind, all of these triangles have a hypotenuse. The hypotenuse is across from the what degree? 90-degree angle. So look, right here's a 90-degree angle on the huge triangle. So this would be our hypotenuse. And then on this medium-sized triangle, right there's our 90-degree angle. So that would be our hypotenuse. And then on this small triangle right here's our 90-degree angle, so we don't know our hypotenuse. Okay? Now, let's go through number 14 together on the worksheet. So if you want to get that out, or if you want to do it on a separate sheet of paper, you kind of need room, the way I taught the other classes. So here we go. So now, first of all, we know we have three similar right triangles, a small one, a medium-sized one, and a large one. Now, if I'm going to have you now split these up instead of just trying to see it all in one, to split it up. So the first thing I would do is go off to the side and draw a small right triangle, a medium-sized right triangle, and a large right triangle. This really helps, guys. So if you'll just take my advice, I really think you'll understand this better. Now notice I face them all the same ways. Now I'm going to fill them in, all the information I know. Okay, so let's focus on the small right triangle and fill in what we know on this. So right here, we know our altitude on the small triangle is our long leg, right, everybody? Okay, so I'm going to go up to my small triangle and put in a Y where the long leg is. Now on my small right triangle, still looking at the green one, my short leg is 4. And I don't know my hypotenuse across from the 90 degrees. I don't know it. Okay, so I filled in my small triangle. Change colors. Now I'm going to fill in everything I know on my medium-sized triangle. Now remember that altitude, that Y value that we dropped down, that altitude on the medium-sized triangle is our short leg. So I'm going to go to the medium-sized triangle, and my short leg is Y. So I put it in right there. And then my hypotenuse is across from the 90 degrees. So what's my hypotenuse? X, so I make sure I put it in the right spot. Across from the hypotenuse across from the 90 degrees is our hypotenuse, so that's X. Did everybody see what I did? And then my long leg is 12, right? Are you all following me? Okay. On yesterday's worksheet. This is what we learned yesterday. Are we following? Is everybody understanding this? Okay. So then we have our huge right triangle. Everybody look at this huge right triangle. Ignore that line, because on the huge right triangle, that line doesn't affect us. This huge right triangle, what's across from the 90-degree angle? Our hypotenuse. Well, what is our hypotenuse in the huge triangle? 16, right? Its entire length. Across from the 90 degrees is this side. So I've got to put it in the right spot. Across from my 90 degrees is 16. And then on this is my long leg, right? This is my short leg on the huge triangle. Does everybody see it? So my long leg is X, and then I don't know my short leg. Does everybody see how I split them up? This will make way more sense if you'll split them up. Questions on how I split it up? Now we'll just set up ratios of corresponding sides. So let's solve for X. And let's make sure that, so let's solve for X. Now you can use the small with the large, the small with the medium with the large, and so on. So you can use, as long as you're setting up a ratio of corresponding sides, you're good. But you don't want two different variables. So let's look at this. Everybody focus with me on the medium-sized triangle and the large. If I did hypotenuse over hypotenuse, wouldn't that be X over 16? So I'm going to write that X over 16 is equal to, now I'm going to have to use this side, so 12 over X. So it's equal to 12 over X. Does everybody see how I set up that ratio of corresponding sides? Now we'll cross multiply and solve for X. So I'll multiply both sides by X, but it divides out over here. Multiply both sides by 16, but it divides out over here. So right over here on the left, I have X squared is equal to 12 times 16, 192. And then we'll take the square root of that, right? so that our root cancels out with our power. And tell me what's the decimal answer of that? 13.85? 13.85? Okay, so 13.9. So we just found x. It's 13.9. Now, let's add up another. We're going to find y. Now, looking at similar triangles, we know we can set up the ratio of corresponding sides. So we could do, everybody look with me now on the small triangle with the medium. Couldn't we do y over 12, y over 12 is equal to 4 over y. Did everybody see how I then set up the similar triangles with the small and medium size? I did y over 12, those are corresponding sides, and then is equal to 4 over y. Those are also corresponding sides. And now we'll cross multiply and solve. Multiply both sides by y, but it divides out over here. Multiply both sides by 12, but it divides out over here. So we have y squared is equal to 48. Take the square root of that. So we get y is equal to the square root of 48, which is decimal. Okay, 6.9. Thank you. Did everybody see that? Did that make more sense today? If you split it up, hopefully that will help you to have it make more sense. Do you want to do one more from the worksheet? And then we're going to move on to the new stuff. Okay. Questions on that? Okay, let's do problem number 19 on the worksheet. Yeah. You could do that, but if you use the y value and then do the Pythagorean theorem, make sure you set the Pythagorean theorem right, and then make sure you use the full decimal. Okay, here we go. So number 19, you have this right triangle on number 19 on the worksheet. Now once again, I would, before I start going on this, split it up into your small triangle, your medium triangle, and your large. Draw those triangles out and then fill them in. So I have a small right triangle. I have a medium-sized right triangle. I'm going to actually draw it better. A medium-sized right triangle. There, better. And a large right triangle. Now notice I'm drawing them so that I can definitely tell which leg is the long leg, which leg is the short leg, and then which leg is the hypotenuse. And I based all my triangles the same way. So then let's fill it in. Let's focus once again quickly on the small triangle here. What's my hypotenuse? 5, so I put my 5 in. My long leg is Z. And my short leg is X. Questions? Okay, now let's fill in our medium-sized triangle. My short leg is Z. On the medium-sized triangle, what's my long leg? Y. And then my hypotenuse, 12. So I'm labeling them off to the side correctly too. Now let's look at our huge large triangle. What is across from the 90-degree angles is the hypotenuse. What's my hypotenuse? 13. What's my long leg? 12. And my short leg? 5. So this is 12 and this is 5. So now we'll just set up ratios of corresponding sides. Okay? So I'm going to solve for one of the variables first. I'm going to go ahead and solve for, I know if you try to set up a ratio and you have two different variables, just try a different ratio because you're not going to use that one. So I'm going to go with this. I'm going to look at the small triangle and the large triangle. I'm going to do 5 over what? What would 5 be to? 13. Both hypotenuses is equal to, and I'll go for x this time. So x over what? 5. Now we'll cross multiply and solve. I'm going to set up while I'm here before I solve that one another trig ratio. I'm going to go 5 over 13 is equal to z, still using the small and the large, z over what? What is z to? 12. Are you following? Is this making more sense than yesterday? Yes or no? Yes. So I can't tell if I'm wasting my time up here. Okay. And then let's solve for y. So let's go with 12 over 13. So now I'm going to do the medium and large. So I'm going to do 12 over 13. Hypotenuse over hypotenuse is equal to y over 12. I set up my trig ratios. Now I'll cross multiply and solve. I'm not going to finish this one. You can finish it. Okay, but did everybody see how really it's not as bad as yesterday seemed? I tried to keep it all together and just have you think about it, but we weren't seeing it. And so I didn't do that. Second hour and they understood it way better. Third hour understood it. So does this make more sense today? Okay, awesome. So just split up your right triangle, set up a ratio of corresponding sides. All right, we really need to get to the new stuff too still. So you still have another day to finish that. It's not due till tomorrow, so we got to move on though. Okay. So I just wanted to go back and touch on that. Okay, here we go. So this is a new thing, guys. Please get out your stuff, your notes, and just get. So we're going to have a triangle that's not a right triangle that has a line bisecting an angle of that triangle. Now, what bisect means is cut it exactly in half. Now, on a right triangle, we dropped an altitude. The angles weren't necessarily being cut equal. Most of the time, they were not being cut equal. But today, we're going to learn how to deal with something when the angles cut exactly equal and what will happen. So this is what the triangle bisector theorem says. If one angle of a triangle is bisected or cut in half into two equal pieces, then the bisector of the triangle, so that line, cuts the triangle's opposite side into segments that are proportional to the other two sides of the triangle. So we're going to have proportions again, just like we've been doing with all of our other similar triangles, and we can just set up the ratio of corresponding sides. So in other words, this is more of the thing that will make sense to you probably. So it says, if angle ABD, so if angle ABD is congruent to angle DBC, so if those two angles are congruent, then you can set up this ratio. You can do AD over DC, because those will be corresponding sides, is equal to AB over CB. So you'll just set up ratios of corresponding sides. So this is much easier than the right triangle one, right? It will be, because it's going to be easy to see. You'll just set up a ratio of corresponding sides. All right, now you really have to, for the test, understand the difference. This is a right triangle that was bisected, but it wasn't bisected. We just dropped an altitude. So a lot of students, after they learn this, they try to do the same thing that we're going to be doing with this, with a right triangle, and you can't. So if it's a right angle and you drop an altitude down, we're not saying that those two angles are cut equal. They won't be, okay, necessarily. So you'll have to use the right triangle stuff, draw your three similar right triangles, and set up ratios of corresponding sides. But the difference is, if you have something like this, where these angles are just bisected, cut in exactly equal halves, we'll be doing what we're doing today, which is much easier. You'll just know that this side over this side is equal to this side over this side. So much easier. All right, so here's our first example. So we know that, once again, this is not a right angle. If it was, we have to draw out our three right triangles. So this angle is being bisected, cut exactly in half. So these angles are equal. So we know we have the ratio of corresponding sides. So we will just do 7 over x, 7 over x, 7 over x is equal to, you got to stay consistent. I went with this triangle first, right? 7 over x is equal to 21 over, yes, is equal to 21 over 18. Okay, do you have questions on how I set up the ratio? Way easier than right triangles, right? Okay, so then we cross multiply and solve. So I'm going to multiply both sides by 18. But it divides out over here. I'm going to multiply both sides by x. But it divides out over here. So then 7 times 18 is 126. So we have 126 is equal to 21 x's. Now to get x alone, you tell me. What do I do? Divide both sides by 21. So then we get 6 is equal to x. X is equal to 6. Very good. Questions on that? Okay. We'll do one more, and then I'm going to just let you practice on the worksheet. Last one. Here we go. Now, we have to be able to make sure you look with me so you can understand why we know. Because on the test, it's going to be a bunch of triangles, and you're going to have to know how to set up ratios of corresponding sides correctly according to what you're looking at. So looking at this, is it a right triangle? No, there's not a right angle. If this was the right angle right here, though, if that green angle was a right angle, we would have to write out our 3 right triangles, right? And we would know that altitude being dropped down would create 2 more right angles. This is just a bisected angle. So those angles are cut equal into 2 equal pieces. So we know we have 2 similar triangles, and we can set up a ratio of corresponding sides. So I'm going to do x plus 2 over x plus 2 over x plus 1 is equal to what? 7 over 5.6. Very good. 7 over 5.6. Questions on that ratio? Then we'll cross multiply and solve. We're almost done. Multiply both sides by 5.6, but it divides that over here. Multiply both sides by x plus 1. Now, do I have to put x plus 1 in parentheses? Yes. Yes, it is in parentheses because it's 7 times that entire side. That entire side is x plus 1. So then, does x plus 2 need to be in parentheses? Yes. Now we'll distribute it through. 5.6 times x, 5.6x, 5.6 times 2. Good. Yep, very good. 11.2, thank you, is equal to, now on this side, I got to distribute 7 through. 7 times x. Good. 7 times 1 plus 7. Now, once again, this class, there's a few people who are still just thinking that with these x's, you can just pull everything together. Can you do that? No, you've got to bring them over from one side of the equation to the other using the correct operation. So this is positive 5.6x. I'm going to subtract 5.6x from both sides. Now over here, that adds up to be 0. We've taken care of it correctly. So we have 11.2 is equal to 7x's minus 5.6x's is 1.4x's. We just added those up and then plus 7. Now remember our goal. People get here and then they get stuck. What's our goal? We're solving for x. How do we solve for x? We get it alone piece by piece. So what's our next step? Minus 7 from both sides. Very good. So 11.2 minus 7, thank you, is 4.2. Very good. So 4.2 is equal to 1.4x's. And then from there, last step. Divide both sides by 1.4 and you got 3. Awesome. So 3 is equal to x, or x is equal to 3. Same thing. Very good. Okay, do you feel comfortable with these? I think you should be. Yeah, awesome. Okay, now you're going to practice problems 7, 10, 12, 13, 16. So yeah, you're kind of jumping around until we get to this next part. That's okay. Okay, practice, work together. Please ask your neighbor if they got the same answer. Okay, we've learned this before. It says think back. So I want you to think back to a few days ago. Now we've been dealing with similar polygons and similar triangles for a while now. We learned that if you have 2 parallel lines in a triangle, then it's going to cut the triangle proportionately, and we have 2 similar triangles. So remember with something like this, we have 2 similar triangles, this small triangle and then the large triangle, right? Right? Okay, awesome. So we learned too, when you have 2 parallel lines, there's 2 types of ratios you can set up. You can set it up like similar triangles, or you can do it like this. 11 over 8, 11 over 8 is equal to x over 9. There's 2 different types of ratios. That's one way of doing it. If you want to just use similar triangles, you could have done 11 over what? 11 over 19 is equal to, because 11 is this side, the full side is 19, is equal to x over x plus 9. X over x plus 9, right? Which one looks easier? Top one, I'm going to use that. Yeah, good point. Now, remember, like we did see, though, it's good to know both, because on the other worksheet, we saw some where this way was easier, down here. It happened to be the algebra was simpler. So just understand that if you have two parallel lines, both of these type of ratios work. Let's use the top one, cross multiply both sides by 9. And then is x alone?
No.
Is x alone?
Yes.
Yes. So 9 times 11. So we have 99 over 8 is equal to x over here on the left. And I don't need to cross multiply by 8. If I wanted to, I could, but then I'll just divide it back over. So 99 divided by 8. 12.375. Very good. So 12.375 is equal to x. If we run around to 1 x small, that'd be 12.4 is equal to x. Okay, that was what we learned. Now today, we're going to extend our knowledge a little bit, but really we're dealing with the same thing. So what if you saw something like this instead? Look over here. Now notice, does it look very similar to what we've already been dealing with? It works the same way. This is really just a triangle because what's happening here is we have these two lines. These two lines, this line and this line, notice how they're going like this, and it doesn't say that they're parallel, does it? No, so they must intersect. If they're not parallel, they must intersect at some point. So they're going to intersect. And then we have these two lines which are parallel, thus they'll never intersect. And so we have this triangle looking thing. Well, it's the exact same thing as this triangle. So you can set up your ratios as such. A over B is equal to C over D. Just like the exact same thing over here. A over B is equal to C over D. So it's just a fancier looking triangle, but it's the same thing. Does that make sense? I just took this line, extended it, extended it, extended it, extended it. Because it's just a different way of looking at it. It's just a different way of. So understanding that, you know, even though if the lines might continue, it's still forming a triangle. Yeah, good question. All right. Okay, so solve for x. Well, looking at this, guys, don't let it scare you. Does it look? Do we really just have a triangle here? Yes, we have these three parallel lines, and they're intersecting the other two sides of the triangle, so it's cutting the triangle proportionately. Now, if we wanted to ignore this top line, wouldn't that just look like a triangle? Yeah? Okay, so we would set up our proportion as 10 over x is equal to 12 over 4. Or you could have done 10 over 10 plus x is equal to 12 over 12 plus 4. So either way. Now I'll cross multiply to solve for x, multiply both sides by 4, but it will divide out on this side. Multiply both sides by x, but it will divide out on this side. So I'll have 40 is equal to 12x, and then what will I do? Divide both sides by 12. So x is equal to, very good. Questions on that? Okay. 2 more examples, and then the rest of the time is yours, so stay with me. So they're a little bit different. So looking at this, it says solve for x. Now looking at this, guys, we have these two lines which are not parallel, thus they must intersect. You can tell from the picture that they're going to intersect somewhere up here. And then also we have these 3 parallel lines, and they're intersecting both sides of the triangle. Thus it's cutting the triangle proportionately. So we'll set up our proportions. Couple different ways to do this one, but make it easier on yourself and use the easier one. We can do 3 plus x over 2x plus 2. So I'm going to do x plus 3 over 2x plus 2 will be equal to, so this over this will be equal to 2x plus 2 over 4x minus 2. Let's go through this one, cross multiply and solve, because this one you have to be very, 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 very careful. And this one, there will be ones this difficult on the test. It's not, but there's a lot of room for error. So we're going to multiply both sides by 4x minus 2 since it's on the bottom. But it divides out over here, right? Okay. I'm going to multiply by both sides by 2x plus 2 since it's on the bottom here. So I'm going to multiply by 2x plus 2, but it divides out over here. Now those things are divided out. Am I okay to erase so I have room? Everybody? Okay. Okay. Now do I need to put all that stuff in parentheses?
Yes.
Yes? I need to. Yeah. And now I have to double distribute on all of this very carefully. So it'd be so sad to really understand it and get it wrong because you can't double distribute and combine like terms. So we gotta be careful. So let's go through and do this carefully. 4x times x. 4x squared. Do not forget that. You guys, you have to have this down because this test you're going to see lots of double distributing. 4x times 3 plus 12x since it was positive. There's not going to be room. That's annoying. And then we distributed 4x to all those terms, yeah? So I'm going to now distribute negative 2 times x. Negative 2x. And then negative 2 times positive 3. Negative 6. Let's combine like terms. 4x squared, no other x squared. 12x's minus 2x's. Plus 10x, very good, minus 6. That's just on the left, right? That's just this piece. Now I'm going to double distribute this side. I'll change colors, and then I'll put them right next to each other before I solve. So now we'll do 2x times 2x. 4x squared. 2x times positive 2. Plus 4x, don't forget the x. 2 times 2x plus 4x. Now distribute 2 through to the last thing, positive 4. Combine my terms before you start moving things. 4x squared plus 8x plus 4. Very good. So now we know that this is equal to this. So I'm going to write that 4x squared plus 4x squared plus 10x plus 10x minus 6 is equal to 4x squared plus 8x plus 4. I set them equal. Now I'm going to give myself okay. So let's go through and bring things over. Can we just float? Okay, please. There's people in this class that retested still. Once again, I say this every time. They're floating things together. You can't just float them together. So if this is positive 4x squared, how do we get it over here? Subtract 4x squared. Subtract 4x squared. What happens to our 4x squareds? 0, 0. Awesome. So they're gone. So right now I have 10x minus 6 is equal to 8x plus 4. Don't just float things together. Use the correct operations. Let's combine our x's. So I should subtract 8x from both sides of the equation. 10x's minus 8x's. 2x's, we still have our minus 6 is equal to that 0, and that is positive 4, right? Add 6 to both sides. So 2x is equal to 10. Divide both sides by 2, and we get x is equal to 5. Awesome. Good. Questions on that? Okay, last one, and then I'm going to let you work. Look up here. This one freaks people out. So if I don't do one like it, I know some of you won't be able to do it. Okay, so look up here. We have these 3 lines. Now, are these 3 lines right here parallel? No, thus they must intersect. And you can tell they're going to kind of go up there and intersect. Okay? And then we have these 3 lines which are parallel. So, and also it's intersecting the other sides of the triangle. So we have these proportions. So now we have to solve for x and y. So we have to set up our proportions. So if you look right here, I'm going to color code it for you. Look right here. So you see how we have a triangle right here. And then we have, okay, so let's set up our ratio using that triangle. 4 over 3x. I won't go through and solve this one all the way. 4 over 3x is equal to 2.5x over 7.5. And we cross multiply and solve for x. Now, once we know x, couldn't we plug it in right there? And we get some number, right? Okay. Now, I got x, if we solve this, we get x is equal to 2. So let's plug it in. 2 times 2.5 isn't that 2? This is 2, so 2 times 2.5 is 5, yeah. So this side's 5. So now look right here with me. Don't we also have another triangle right here? Yeah, so we could set up 5 over 7.5 is equal to 13 over y. And then could we solve for y now? Okay, awesome. Now, do you guys all feel comfortable with this? Okay, awesome. So these are the problems you'll do. Do all of the problems except for number 17. You can't do it because we haven't learned how to solve quadratics yet. Number 11 is bonus. So for you advanced thinkers, if you want to push yourself, number 11, you will have to use the Pythagorean theorem at some point in that. So there you go. That's your homework, so work till the end of the hour, and then if you finish that, pull out your other worksheet and work on that.